Okay, the time has come. We're going to solve equations with lots of steps in them, okay? So in the previous two worksheets, we looked at the addition property of equality and the multiplication property of equality, and those two properties are really important in helping us solve an equation. So a couple of things I want to remind you of. First of all, our goal is to solve by isolating the variable. We do this by undoing what has been done to the variable. And then a brief word of caution, make sure you maintain balance. So when you get an equation, it's automatically balanced. The left equals the right. And as we do these steps to undo what has happened to the variable in order to isolate it, we have to make sure we maintain balance. So if I do something to the left, I have to do that same something to the right, okay? Now, I've alluded to this idea of linear equations. Linear equations are any equation of the form ax plus b equals c. We have a single type of variable. Now, this is a very simplified equation, okay? We're certainly going to have things that are more complicated looking, but you have a single variable type. So it doesn't mean you're going to have a single variable in your equation. It means you're going to have a single type of variable. So all x's or all y's or all p's or all r's or all n's, whatever. And then the big thing you have to understand is the variables have to have an exponent of 1. That's what makes it linear. If you had an exponent of 2 or 3, it's no longer a linear equation, and that is for much later down the road in this course, okay? So all of our equations are going to have a single type of variable. The exponents on those variables will be 1, okay? Now, using the properties together, again, in the previous two videos, we talked about the addition property of equality and the multiplication property of equality. The addition property of equality allowed us to move things by addition or subtraction from the left hand to the right hand or vice versa. The multiplication property of equality allowed us in that final step, when we get to that final step of the equation where we have a single variable term equaling a single constant term, the multiplication property of equality allowed us to multiply or divide by the coefficient of the variable to ultimately isolate the variable. So now when we use these properties together, the first thing we want to do is make sure the left and right hand sides are as simple as they can get, okay? And then we want to apply the addition property of equality first. That's going to help us get a single variable term equaling a single constant term. And then at the very end, we apply the multiplication property of equality. Okay, so let's look at an example. And I think I'm going to do one video for the first two topics here. So it'll be a little bit of a longer video, but I think these two things go together nicely. Okay, so example 1 says solve each equation, check the solution, okay? A lot of these questions are going to say check the solution. We're going to get in the habit of not checking every single solution just for the sake of time, but practice it, make sure you know how, okay? So for part A, we have 3x minus 12 equals 0. So our goal ultimately is to get a single variable term equaling a single constant term. We have a single variable term, but it doesn't equal a single constant term. We have a variable term minus 12 equaling another constant. So we need to get that variable term all by itself on one side of the equation. So we want to isolate the 3x first. The issue is minus 12. So ask yourself, how could I undo subtraction of 12? Well, we would add it. So I'm going to add 12, but if I add it to the left, I have to add it to the right. So I'm going to add 12 to both sides of the equation. On the left, negative 12 plus 12 is 0, okay? 3x minus 0 is just 3x. Remember, a lot of times people will be like, oh, the 12s cancel. Get used to hearing that. But just know in your head, the 12s don't just disappear. 12 minus 12 or negative 12 plus 12 is 0. So it cancels to become 0. And then 3x plus 0 is just 3x. And then on the right, 0 plus 12 is 12. So we get 3x, a single variable term, equaling 12, a single constant term. So now we can apply the multiplication property of equality. Okay, so the multiplication property of equality allows me to multiply or divide both sides by the coefficient of x. Remember, we're undoing what has happened to the variable. Well, this variable x has been multiplied by 3. I want to undo that multiplication. So in order to undo multiplication, we use division. So I'm going to divide both sides of the equation by 3, which is the coefficient of x. And notice on the left, 3 divided by itself is just 1. Anytime you take a number and divide it by itself, it equals 1. So we just get 1 times x, or just a single x. Now on the right, 12 divided by 3, positive divided by positive, we're going to get positive 4. And we have plenty of time. This is going to be an easy one to check, so let's check. So I'm going to take the original equation. Anywhere I see an x, I'm going to replace it with a 4. So I get 3 times 4 minus 12 is 0. So 3 times 4 is 12. I need to subtract 12, and hopefully we get 0. Well, what is 12 minus 12? It's 0. So does 0 equal 0? Certainly. So we could say the solution here really is 4. Okay? So let's try another one. So part B, we have 19x minus 2 minus 7x equals 16. So let's see what happens here. So first of all, on the left-hand side, I have two terms that need to be combined. You always want to look to see if you can simplify by combining like terms. So 19x minus 7x, we just take 19 minus 7, and that equals 12. So we get 12x. Don't forget your minus 2, and that equals 16. Okay? Now, I need to get that 12x alone. In order to apply the multiplication property of equality, I have to have a single variable term equaling a single constant. That minus 2 is messing us up. So let's go ahead and apply the addition property of equality to move that 2. So the way we would deal with minus 2, the way we undo that is we would add 2. So I'm going to add 2 to both sides of the equation. Well, on the left, negative 2 plus 2 is just 0. So again, we say, oh, these cancel. They cancel to become 0. So 12x minus 0 is just 12x. And then 16 plus 2 is 18. Okay? So now we're at that point where we can apply the multiplication property of equality. We have a single variable term equaling a single constant term. So our goal is to undo, remember always, to undo what's happened to x. Currently, x has been multiplied by 12. We want to undo that multiplication. We undo multiplication with division. So I'm going to divide both sides here by 12. So on the left, 12 divided by 12 is 1. Anytime you take a number and divide it by itself, you just get 1. So I get 1 times x. And then as far as 18 divided by 12, this is something that some math students kind of have a hard time with. Use caution. The improper fraction is fantastic. We rarely ever need to use a mixed number. The only time you'd use a mixed number at this point in your career is potentially if you had like a word problem where the mixed number makes more sense. Decimals are appropriate. You'll see decimals from time to time. But generally speaking, if you start with integers, or you start with fractions, you end with fractions. So at this point, just simplify your fraction. Don't worry about writing it as a decimal. Don't for sure worry about writing it as a mixed number. Get into the habit of just understanding an improper fraction. Fantastic. So 18 and 12 are both divisible by 6. So we're going to divide both of these by 6. Well, 18 divided by 6 is 3. 12 divided by 6 is 2. And there you have it. That's our final answer. So if you need to, go ahead and just double check it. So we get 19 times 3 halves minus 2 minus 7 times 3 halves equals 16. Now, I am for sure going to cheat here and use the calculator. Let me get the problem in front of me so I don't forget it. So I'm going to go to a calculator just for the sake of time again. We could do this by hand. This one's a little more complicated, so I would completely expect you all to use a calculator. But let's see here if I can go to my calculator. Okay, so I've got my calculator. And what we're going to do is we're going to type in that equation. We're going to replace all of our x's with 3 over 2, okay? So I have 19. You've got different ways you can write 3 over 2 with a calculator like this. This is the TI-84. This is the recommended calculator. It's very general. It does everything you're going to need it to do while you're here. So this is the one I use. I would go ahead and do 19 and then just automatically do parentheses. The multiplication is applied. You can get your calculator to type in a fraction. It'll do it a few different ways, and it depends on the calculator. So I'm going to do kind of the more generic path to get it to type in a fraction, just because not all calculators are the same. So you go alpha, this green button, and then hit y equals, and it's going to pull up this menu. The very first option is n over d, so think numerator over denominator. We want to use that option, so I'm going to type in 1, and then I type 3 over 2. I'm going to go out to the right just so I get in front of the 3 halves and then hit my parentheses. We had minus 2, and then we had minus 7 times 3 halves. So I'm going to go alpha y equals, make sure you get your parentheses. I'm going to choose option 1, and I'm going to go 3 over 2, parentheses, and we want this to equal 16, so let's see what we get. We get 16, so we can verify that this works out. You could also do 19, and instead of just doing that fraction feature, you could start parentheses and then do 3 divided by 2 minus 2 minus 7 times 3 divided by 2. This is exactly the same thing as above. It's just it shows the fraction a little differently. So we get 16. Whoops, I didn't mean to hit equals twice. You could also understand that 3 halves is 1.5. Now, we would always write it as 3 halves for our answer, but it is the same as 1.5. So we could go 1.5 minus 2 minus 7 times 1.5 better equal 16, and it does. Okay, so we have verified in a few different ways that our answer to the left-hand side of the equation really is 16, so is the right. Let me plug my computer up. It's about to die. Sorry. Okay, so let's go back to the worksheet. So we can say officially 16 equals 16. That's true. So our solution is indeed 3 halves. Okay. Now I did say I was going to make one video for topics 1 and 2. So let's go ahead and look at topic 2. So topic 2 is solving multi-step equations. So this is where you get all sorts of simplifying that has to happen before you can even get to applying those two properties, okay? So we do need to remind ourselves of one thing. We have this thing called the distributive property. The distributive property allows us to eliminate parentheses by multiplying through a sum or a difference. And then I've shown you what the distributive property looks like. Basically, you're going to have something multiplied by a set of parentheses. In this case, this something A has to be multiplied by everything inside those parentheses. So we have to take the A and multiply it by the B. We have to take the A and also multiply it by the C. So that would give us AB times, or AB plus AC. You could also do this with subtraction. We want to take this A and multiply it by the B. We then want to take the A and multiply it by the C. So we would get AB minus AC. You could also expand this. I could have A times B plus C minus D. Okay, throw in some different signs there. Positive times a positive is positive. Positive times a positive is a positive. Positive times a negative is a negative. So you could have more than 2 terms in parentheses. You can have all different signs. All I ask is that you fully distribute and you watch your signs. Okay? Now, there are steps to solving an equation, and if you follow these steps, I promise you you're doing it the most efficient way possible. If you start to do things out of order, you're adding more work to yourself, okay? Students are always like, do I have to show that step? Can I take a shortcut? Well, here's the one chance I'm giving you the shortest way to do it, and then y'all make all these extra steps. So do as I say, okay? Follow these steps, and I promise you it's the easiest way to solve an equation. Okay, so when you have an equation that has like loads and loads of steps to it, okay, first thing you want to do is apply the distributive property to get rid of parentheses. So first thing you do is get rid of parentheses, period. Don't add, don't subtract from both sides, get rid of your parentheses. Once you do that, you want to simplify the left-hand side of the equation and simplify the right-hand side of the equation separately. So get rid of parentheses and then combine like terms, okay? Once you have at most 2 terms on each side, that's when you do the addition property of equality. So you apply this when you have at most 2 terms on each side. And those terms are not just any old terms. You have at most a variable term and a constant on the left, and at most a variable term and a constant on the right. And that is the first time you start adding and subtracting things from the left to the right. Okay, so once you get to this point, so we would have like AX plus B equals CX plus D. Once you get to this point, you apply the addition property of equality. Your goal is to get all of the variables on one side, all of the constants on the other. At that final step, you apply the multiplication property of equality. Okay, so let's go ahead and look at these examples. Do not be freaked out. They have lots of steps, but we're going to take it one at a time. Okay, so for example 2, it says solve each equation. All right, part A, we have 2 times parentheses 3x minus 2 minus 2 times parentheses 5 minus 2x equals 4. We have 2 sets of parentheses. Let's get rid of them right off the bat. Don't try to add anything. Don't try to subtract anything. Just distribute. Okay. So for the first set of parentheses, I need to distribute a positive 2. So I take 2 times 3x, so I just multiply 2 and 3, which is 6, and then I keep the x. I then take 2 times negative 2, so treat that minus 2 as a negative. So 2 times negative 2 is negative 4. And then I'm going to distribute this negative 2 through the second set of parentheses. So negative 2 times 5 is negative 10. And then negative 2 times negative 2x is going to be positive 4x. And all of that equals 4. All we have done so far is distribute. Okay? We distributed through the first set of parentheses. Then we distributed through the second set of parentheses. At this point, don't you dare start adding and subtracting from both sides of the equation. Think of it like this. When you move, like move from one apartment to the next, you load up one big truck and you move it from one house to the next. If you start moving things left and right here, it's like moving your house one box at a time. It's ridiculous. You're going to lose things, okay? And it takes way more work. So you want to load up the truck and move one truck at a time, okay? So you do not start moving things yet. Instead, we're going to combine like terms. Think of that combining like terms like loading up that moving truck, okay? So I happen to see that I have x terms and I have constant terms. So let's look at the x terms first. I have 6x plus 4x. That's just 10x. And then I have negative 4 minus 10. So negative 4, subtract 10 more from that, we get negative 14. All of that equals 4. Okay, so at this point, I have a single variable term, which is awesome. I need to get the variable term alone, so I need to move that negative 14 moving truck. Okay, so I want to move my minus 14. We need to undo the subtraction. We undo subtraction with addition. Okay. And so at this point, negative 14 plus 14 on the left, that just becomes 0. So again, people say it cancels. Just no, it cancels to become 0. So 10x minus 0 is just 10x. And then on the right, I get 4 plus 14 equals 18. Okay. So at this point, I can go ahead and apply the multiplication property of equality. I have a single variable term equaling a single constant term. I need to undo what has happened to x, and at this point, what's happening to x is it's been multiplied by 10. So let's divide both sides by 10. 10 divided by 10 is 1, and that's always the case. If you take a number and divide it by itself, you just get 1. And then 18 divided by 10. We could technically write this as a decimal. We could technically write this as a mixed number, but you just don't. At this point, when you're just solving these generic equations, you leave your answer as a simplified improper fraction. That's just the way we do it, okay? There are times where the decimal is appropriate. There are very few times where the mixed number is appropriate, but 9 times out of 10, you just leave it as a mixed number, or as a, not a mixed number, an improper fraction. So let's see. 9 and 10 are both even, so they're at least divisible by 2. So let's start simplifying. We're going to take 9 and 10 and divide them by 2. Well, 9, let's see, 9 and 10. Bless my heart. I swear I know what I'm doing. 18 divided by 2. 18 divided by 2 is 9. And then 10 divided by 2 is 5. So now, do 9 and 5 have any common factors? No. 5 is prime. The only factors that make up 9 are 3. So at this point, you're done. We would say our final answer is 9/5. And I promise you, this is the quickest, most concise, and precise way to get that final answer. Okay, so don't stray from my steps. All right, part B. This will be the last one for this video. We have 4 times 3x plus 4, and then minus 20 equals 3 plus 5x. Okay, so let's start by distributing. We have one set of parentheses. We need to get rid of those. So I have this 4. I want to multiply it by the 3x and by the 4. So 4 times 3x, we multiply 4 and 3 and get 12, and then we just keep the x. 4 times 4 is 16. And at this point, just rewrite the rest of the equation. So I want to write minus 20 equals 3 plus 5x. And again, at this point, don't you dare start adding and subtracting stuff from both sides of the equations. Again, that's like moving a whole house without loading up the moving truck. We want to load up the moving truck. We want to simplify both sides of the equation as much as we can. We want to get both sides of the equation to where they have at most 2 terms. You should never add or subtract more than 2 things from either side of the equation, ever. So you should be adding or subtracting at most twice, okay? So the left-hand side of the equation is what needs some work. We have some like terms. We have these two constants that can be combined. So I'm going to keep my 12x. I'm just going to rewrite it. But then 16 minus 20 is -4. So think you have the temperature is 16 degrees. It drops 20 degrees. Where's it at now? It's at -4. So we're going to write -4 as -4. And then we have 3 plus 5x. So let's look at this. Earlier, I told you that you don't want to apply the addition property of equality until you have something that looks like this. Variable term plus constant equals variable term plus constant. So this right here. And if we go back to our equation, we are exactly, where are we at? We are exactly there. Okay, we have a variable term and a constant, a variable term and a constant. So now we can apply the addition property of equality. Okay, so let's start with the variables. I always like to deal with my variables first, constant second. So I have 12x on the left, I have 5x on the right. As a mathematician, I always move my variables to the left. There are a few times, especially with word problems, where I'll leave the variables on the right, but generally I move them to the left. So I want to look at that 5x. It is a positive 5x. So we're basically adding 5x to the right. I want to move it. The way I undo addition of 5x is subtract. So I'm going to subtract 5x from both sides. Well, on the left, 12x minus 5x is 7x. Don't forget your minus 4. Don't forget your equals. And then on the right, we're left with just 3 because 5x minus 5x is 0. 3 plus 0 is just 3. So we say those 5x's cancel. Remember, they don't just disappear. They cancel to become 0. Okay? So we've done one move. We're allowed two. We're allowed to add or subtract only twice. Okay? So we've done one. We've got one more. Our goal is to get the variable term by itself. The issue now is -4. How would I deal with -4? Well, to undo subtraction, I would add. So I'm going to add 4 to both sides. Okay? Well, on the left, -4 plus 4 is just 0. 0 plus 7x is 7x. On the right, 3 plus 4 is 7. So we finally got it to that point where we have a single variable term equaling a single constant term. We now apply the multiplication property of equality. So I need to undo the multiplication of 7 and x, okay? Whoops, give myself a little more room here. There we go. Okay, so we need to undo the multiplication of 7 and x. 7 times x, the way we undo multiplication is division. So I'm going to divide both sides of the equation by the coefficient of x, which is 7. 7 divided by itself is 1. So a lot of times we'll say, oh, the 7's cancel. They don't just disappear. 7 divided by 7 is 1. 1 times x is x. And then again, 7 divided by 7 is 1. So there you have it. So two multi-step equations. We looked at how to solve them, get rid of parentheses. Once you get rid of parentheses, don't you dare start moving stuff across the equal sign. Combine like terms next. Simplify the left, simplify the right. Once you get at most 2 terms on the left and right, one constant term, one variable term, then you can start moving things. That's when you apply the addition property of equality. And you apply the addition property of equality at most 2 times. If you apply the addition property of equality more than 2 times, you're doing it wrong, okay? And then finally, once you get a single variable term equaling a single constant term, then you can apply the multiplication property of equality. So make sure you practice examples like this. Make sure you're really solid at solving equations. In the next videos, we're going to look at dealing with fractions and decimals.